We continue with our discussion on NMAP. If you recall, in the last lecture we talked about specifically the host discovery kind of commands that is there, but here in the part 2 of the lecture we shall be mainly talking about port scanning. Sorry, this should be port, P-O-R-T, port scanning using NMAP, and so this is actually port. There is a typographic error, and various ways in which we can carry out this port scanning. Okay. So, let us see. First thing I mentioned during the last lecture, what do you mean by a port is open or not? Suppose when you have a server machine, suppose there is a server, there can be several services which are running on these machines, and each of the services will be listening to a particular port number. Like I said, service like Telnet usually listens to port number 23, Mail SMTP listens to port number 25, and so on. So, we say that the server or service is listening on that port number. Whenever there is an incoming request on that port number, the request is forwarded to that server. So, here we are basically trying to find out what services are running, which means they are listening on a particular port number. As I said, each running TCP service is associated with a specific port number, where the server or service listens for incoming connections, as I said. In contrast, for UDP services, only the port number is associated with it, it does not listen on that port. So, the way UDP and TCP servers are implemented are slightly different. TCP servers listen on a port, UDP servers do not listen. So, it is like connectionless, we call it. Okay. Now, there are several port scanning options which are available in NMAP. Some of this we shall be talking about: TCP connect scan, TCP SYN scan, TCP stealth, and FTP bound scan. Okay. Let us see about these. First, we talk about TCP connect scan, but before we talk about it, let us recall on the right hand side we have shown the connection establishment phase in TCP. When a client wants to establish a connection to the server, there are 3 packets which flow back and forth. The first packet goes with the SYN flag set, we call it a SYN packet. A packet comes back from the server with both SYN and ACK flag set, we call it SYN ACK packet, and finally the client sends back a ACK packet with ACK flag set, and then we say that the connection has been established. So, this is a 3-way handshake protocol. Now, in TCP connect scan, we basically utilize this mechanism of connection establishment. Okay. So, the attacker or the person who is mounting this kind of a host discovery or port scanning kind of a thing tries to complete the 3-way handshake on particular port numbers, and if it finds that this kind of 3-way handshake is successful, this will mean that the particular port number is presently open. There is a server which is presently listening on that port number. Okay. So, pictorially I am trying to show it here that the scanner is first sending a SYN packet on a particular port number. The target, if the service is running on that particular port, it will be sending back a SYN ACK, and scanner will finally send back an ACK. So, you conclude that the port is open. But if you send a SYN packet to a particular port, and if the particular port is not having an associated server running, service running, the machine typically sends an reset acknowledgement packet back with a reset flag set, indicating that it wants to terminate the connection. The server is not there. So, if such a packet comes back, you conclude that the port is closed. Now, the point to note is that this kind of a mechanism can detect a port is open or not, but the system administrator can easily detect this by looking at the system log, because all TCP connections are logged in the system log, and this is a valid kind of a system connection, TCP connection you are trying to establish. So, this will also go into the log. Okay. Fine. There is another kind of this kind of a, you can say, port discovery mechanism called TCP SYN scan. Here the mechanism is slightly different. Well, here also you look, we are utilizing the three-way handshake, but we are sending a SYN, we are getting back SYN ACK, but the third ACK we are not sending. That means we are not completing the connection. If the connection is not completed, then the information will not go into the log. So, you can also escape detection in that way. So, you do not establish the complete connection, sometimes it is called half open scanning. So, if you send a SYN packet, if you see that SYN ACK is received, then you can conclude that the port is listening. You do not complete the connection, instead of sending an ACK, the scanner immediately terminates connection by sending a reset packet. If a reset packet is sent, the connection is terminated immediately. But if this SYN ACK, or if the server is not up on that port, then instead of SYN ACK, a reset ACK will be received. Then you conclude that the port is not listening. Pictorially you show it like this. In the first case, when the port is open, you send SYN, you get back SYN ACK, you immediately terminate connection by sending reset. You do not allow the connection to complete, because your objective is not to complete the connection, right, just to see whether the port is open or not. If the port is closed, then if you send SYN, you will be getting back reset acknowledgement. That is how this works. Okay. So, let us look at some examples. Both these scans I am showing together. There is an option in NMAP -ST which uses both TCP SYN and TCP ACK request packets. It also uses ICMP, that means it uses multiple ways of discovering a host and also looking for the port numbers. So, here I am showing a couple of examples. Here we are using -T on ST with port number 22 on a particular host. So, you see, after scanning, the conclusion is this port number 22 on TCP is currently closed, because you are not getting back a response. So, NMAP one IP address, one host up, the host was up, but this particular service was closed. Let us take another example. Similarly, ST on port number 135 on some other IP address. Here it says that this service is presently open, and also the service number you can see in both cases what this port number corresponds to. Okay. So, here also it says that one IP address is scanned, the host was up, and also this shows that the service was also up, the port number is open. Okay. Let us take another example. Here we are giving -ST with packet trace option, so that you can get the detail. Here also you are scanning port number 22 on a particular host. So, you see here you can see all the packet trace, what packet was sent. Okay. So, all the details, the type of the packet, ID, sequence number, for the IP packet the time to leave, ID, IP length, everything. The final conclusion is host is up, but this service is closed. So, you sent, see, 3 TCP packets were sent, and based on that your conclusion is the packet is, or the particular port is closed. So, if you analyze the packets, you will know that why this conclusion is there. You look at the flags, whatever is coming, you can conclude that the other side is not responding. Okay? Fine. There is another example. Here also you use -ST with packet trace, but now the port is open. So, you see when you send, there are some connection responses that are coming back. Okay. So, because you are receiving the connections and final one is connected after three-way handshake, the connection it is finally connected. So, your conclusion will be the particular port is on that machine, on that host is open. So, you see when you do a network scan, when you try to look at vulnerabilities, the first thing you look at is what are the hosts that are up, and second thing you look at is that what are the port numbers that are currently open on those hosts. Once you know that, you can try to run some exploit on those port numbers which are well known to exploit those vulnerabilities. Okay. Fine. There are some other kind of more sophisticated scan. This is called TCP stealth scan. Stealth is something, as you know, the term stealth means you are hiding, no one will be able to detect you. That is the idea. So, here the idea is you carry out port scanning while avoiding detection, but what is the basic philosophy, how you can avoid detection? Let us try to get an idea. So, your packet means your packets are hiding within normal network traffic. So, the firewall or the intrusion detection system, whatever you have installed on the target machine, they will not be able to distinguish your packets as some kind of malicious packets. Okay? And they will also not be logged, because they will appear to be very harmless. That is why they will not be logged. That is why we say that they are stealthy. And how it works, you see, there are several ways in which you can do this. I am not going into the detail again. There is something called inverse mapping which is utilized. There are probe packets, just like UDP scanning you just saw earlier, that the response will be sent back from the target only when the port is closed. That means the reverse. If the port is open, nothing will be sent back, but if it is closed, then only it is sent back. Okay? So, intruder determines what service do not exist. Then if you take them out, you will know that what service are actually running, the ones that exist. So, this is what is, and this is difficult to detect because you are not looking for hosts which are up or ports which are open, but on the other way around, you are looking for ports which are closed. So, unnecessary, if you are looking for port which are closed, they will not be get logged. Only for active services things get logged. So, these typically will not be so easy to detect and needs long history log. And secondly, you send this kind of packets very infrequently, only few such packets in the whole day. So, that the IDS will also not suspect that these are some malicious packets which are targeted to the host, very infrequent. Okay. All right. So, here we briefly try to tell you one way in which this can be done. You see, every internet service that are implemented, there is a corresponding documentation available based on which the implementation is carried out. These are called RFC documents, request for comments. For example, this RFC 793 is the number of that document number. It talks about how a host should handle wrong packets. The idea is that the scanner, when it tries to, let us say, establish a connection, it is sending a wrong packet, the probe packet. Let us say it is sending a reset packet or a packet with the fin flag set to 1, fin means finish. So, these are normally not the packets with which you are initiating a connection. So, these packets are so called wrong packets to the target. So, the target, if it does not sends back any response, it means it is a wrong packet, it has ignored, which means the port is open. But according to this RFC 793, if it sends back an RST ACK packet, this RFC says that if the port is closed and if such a packet comes, that you need to terminate or reset the connection, then you conclude that the port is closed whenever the response comes back. This is the inverse mapping. If the port is closed, then the response is coming. If the port is open, then the wrong packet is ignored, nothing is coming back. Okay. This is the idea behind TCP stealth scan. Okay. There is another way, this is called FTP bound scan. You see, whenever we establish a connection with the FTP server to transfer a file, there are two connections that are actually established. One is called a control connection, other is called the data connection. Control connection is established to send the FTP commands, and the data connection is established to actually send the data. Okay. Now, the idea behind FTP bound scan is, suppose the scanner is trying to mount some kind of a discovery exercise on a target, and it is utilizing an intermediate FTP server for doing that. So, what it does, it sends back it establishes a control connection with the FTP server and initiates a data transfer connection. So, what it does, you see, FTP server, let us say, it has an IP address 10.0.0.4 and the target has an IP address 10.0.0.5. So, when the request comes, it spoofs the IP address, it changes the IP address to 10.0.0.5, which is the target's IP address. The FTP server is receiving this kind of a packet. 22 means the connection for the data, 21 is the control connection, 22 is the data connection. So, when the FTP server receives such a spoofed packet, it will try to establish a data connection with 10.0.0.5. That means, this will be a TCP connection again. So, it will be sending a TCP SYN packet, it will be, but the target, you see, the connection was established with the FTP server, the target does not know about it. The target will send back a reset packet to reset the connection. It will say, and when it comes back to this FTP server will be sending back a message to the scanner that it cannot build data connection. So, the idea is that via the FTP server, the scanner is getting a response back from the target, and through this target, that means some packet is bouncing back, and if such a response comes back, it will know, it will conclude that the target was up and running. Okay. So, this is called FTP bound scan. So, on this particular port number, the target was running. So, here actually I am not showing examples for these, but I am showing some other port scanning options here. Well, you can give, we already saw earlier, -p option to specify some port numbers, and you can also specify a range of port numbers. Like here you see -p 135-200. So, all port numbers in this range will be scanned on this particular host. So, the scan is carried out and the final conclusion is these two ports only are open, port number 135 and port number 139. So, out the other port numbers are all closed. So, it says this one IP address was scanned, this one host was up, and these are the two services which are open on that machine. This is how you can specify a range of port numbers. Let us look at some more examples. You can give a -F option. -F actually refers to fast mode. Fast mode means that you are not scanning all the ports on the target host, rather you are scanning fewer number of ports, the ones which are most common. So, when you scan a particular host with the -F option, this will also look for open ports, but not all. Few number of ports will be scanned, and in that way this process will be much faster. So, for example, if you scan this, it will respond with some open ports 135, 139, 445 and 5357. These are some applications, the names of the applications are also shown here. These are presently open. Okay. So, this scanning with -F option will make the process faster. Let us also look at another kind of a flag, where you are using an option called --top ports. This talks about the most commonly used ports. If you give this option with a number, the three most top ports, topmost used ports will be scanned. So, here you see the three top ports are scanned, Telnet, HTTP and HTTPS, and a summary report is presented. All these three are closed presently on this host. Okay. So, you can scan some host with this top ports, you can specify how many top ports, 3, you can specify 10, whatever. So, those number of ports will be scanned. Here you are specifying something called IP protocol scan using the -SO command. So, if you specify -SO with a particular IP address, then you specify all the protocols and you get a list like this. This is called IP protocol scan. So, what are the protocols which are currently open? Some of them are open or filtered because you are not getting back the complete response back, maybe they are filtered, but some of them are unconditionally open, like ICMP is open, TCP is open, UDP is open, these services are open. Okay. But there are several others which may not be open, but the protocol number, you see these are not the port number, these are the protocol numbers. With respect to the IP protocol, all higher level protocols that run at the transport level or higher level, they have a unique number, like TCP has a number 7, UDP has a number 17. So, this ICMP has a number 1 and so on. So, this scan is carried out based on the protocol number, not on the port number. Okay. So, this is a different kind of a scan where you get information about the open ports with respect to protocol numbers. So, it depends actually why you need this. Depending on your requirement, you will have to use the correct kind of scanning option. So, to summarize, for port scanning, this NMAP supports a number of different options, like for instance, for scan techniques you can specify so many options minus SS, ST, SA, SW, SM. These are basically TCP, SYN, connect, ACK, window and various other kind of scanning options. All of those I have not mentioned at all. There are SN, SF, SX. These stand for TCP null, FIN, XMAX. You see this SX, for example, stands for a Christmas scan. Well, why it is called a Christmas scan? Because you are sending a TCP packet with all the flag set, push, FIN. That means as if your packet is glittering like a Christmas tree. When it reaches a router, router will find that so many flags are on, it will possibly allow the packet to go through, thinking that it is an important packet, it is a high priority packet. Okay. Push flag is also set. Okay. Fine. Similarly, you can mount the FTP bound scan. I have not shown the example using the -B option. These you can do. And when you specify ports, also scan order, there are various options you can use. -P already we have seen, you can specify port ranges, you can specify a particular port, you can specify a range of port, you can specify some specific UDP and TCP ports also, like you can specify -P U colon these, that means these refer to UDP ports, T colon these refer to TCP ports, 21-25 means range, 80, 139, 80, these are all TCP ports. So, you can specify a combination of TCP and UDP port numbers, specific port numbers also. F we have seen fast mode, where you scan fewer ports than the default scan, where you scan everything. -R is consecutive scan one by one. There is a randomization option which is default, the ports are scanned in a random order. Top ports also we have seen the examples with some number, that how many top ports you want to scan. Okay. So, with this we come to the end of this lecture, where we basically talked about different ways in which you can identify the port numbers on some host or a set of hosts that are open. In the next lecture, we shall be continuing with our discussion and talk about some more options that are available in NMAP for operating system discovery, some other services discovery and some common NMAP commands at the end. Thank you.